Let's say we want to use a reflective device such as the EMX IRB-RET. The 936 and 1050 boards can both be used with 300 Hertz pulse output monitoring devices, and these can be used instead of or even in addition to the Blue Bus photo eyes. So this EMX IRB-RET can be set up in a 300 Hertz pulse output, and we can reconfigure inputs on both the 936 and 1050 boards to use this as our monitor device. So to connect an EMX IRB-RET to a 936 or 1050 board, the first thing we have to do is configure this unit properly. The first thing that has to happen is our program switches here. Program switch number 1 has to be on. 2, 3, and 4 need to be in the down or off position. Then there are 4 jumpers in this unit. All 4 of the jumpers, there's a jumper here, and there's 2 more jumpers underneath this upper circuit board here. All 4 of these jumpers need to be on the left hand and center pin. So the 2 jumpers behind this board are actually configured this way from the factory, but this jumper here and this jumper here, if you see, we can actually remove this jumper, and there's 3 pins there. We need to make sure that this jumper is on the left hand pin and the center pin on both this jumper and here. Then it's going to be a 4-wire connection. We are not using the relay output of this photo eye. We are using the pulse output and the VRX terminals. So the 2 terminals marked VRX are going to be our power and ground. As you can see here, we have a black wire to one side of the VRX, a red wire to the other side, and then we have a blue and white wires to our VRX terminals. So this is the proper configuration for an EMX IRB-RET to either a 936 or a 1050 board to use this device as a 300 Hertz pulse monitor device. Again, program switch number 1 on, 2, 3, and 4 off. All 4 of our jumpers on the left-hand pin and the center pin. And then 4-wire connection, 2 wires to VRX, and the 2 wires to the pulse output terminals. We are not using the relay. Okay, so we have our EMX IRB-RET hooked up in the photo eye itself. Program switches set correctly. Switch number 1 on, 2, 3, and 4 off. Jumpers all set correctly, all on the left-hand side and the center pin. Now we're ready to connect to the board. So our 2 wires from VRX, those are our power and ground. On a 1050 board, we're going to connect them to 24 volts and ground at terminals 20 and 21. What's nice about this is a regulated source of voltage that when the board goes into standby mode on a solar application, if we're putting the board into standby mode, this voltage here will turn off. So this will also turn off our photo eyes so that they're not drawing power all the time when we don't need them, okay? Then our 2 wires from E and C will connect to either auxiliary input number 1 in ground or input number 2 in ground. In this case, we're going to be using auxiliary input number 2. Now, the wire that comes from C is our actual input, so it'll go to input number 2, and the wire that comes from E as our ground goes to ground. Now, our photo eye is powered up, and we have a green light blinking on the photo eye, and when we establish the beam on the photo eye, we'll get a red and a green light on solid. This indicates that our photo eye is now aligned and working properly. When we break the beam, the green light will flash, and when the beam is reestablished, we'll have red and green on solid. Now on a reflective photo eye, or any photo eye for that matter, it's important to find the center of that beam and make sure that the reflector is in the center of that beam. Also, hoods over the reflector and over the photo eye itself are very good ideas so we can keep glare and rain and moisture off the photo eye. Anything we can do to make this photo eye more reliable is going to really help us out here. So we've established the beam, and now on the board we'll see that on that auxiliary input we have a dimly lit red light. Shows that we're getting a 300 Hertz pulse output from that photo eye to the board. Now when we break the beam, that light goes out. When we reestablish the beam, the light comes back on. So that indicates that our photo eye is working. Now the next step is to tell the board that this is going to be a monitored input here. Okay, so we go to functions, we go down to number 2, number 3, auxiliary I/O. Auxiliary inputs and outputs, and press OK. Auxiliary input number 1 is by default set to step. Now we're not using that input, so we don't really care. And we go to auxiliary input number 2, you'll see that it's also default set to step. So we're going to change that. We're going to press OK, and we're going to scroll through all the different all the different options for this input, and we're going to change it to either pulse open or pulse close. Now pulse open would be a 300 Hertz pulse input that it's monitoring that on the opening cycle, where like if we had a photo eye set behind the gate as it opens for an entrapment point. Pulse close protects as the gate is closing. So let's say if we're shooting the photo eye across the driveway and we're protecting as it's closing. So we're going to choose pulse close in this situation. Now because we're programming this board, again we selected learn, swing, and average. Because we're programming it as a swing gate operator, it's going to make us connect at least one monitor safety device. If we programmed it as a slide, it would require at least 2. One on the opening, one on the closing. So here we've got our 300 Hertz pulse device connected to auxiliary input number 2. When we're not breaking the beam, we have a light there. We've got the board ready to learn. We've got our limits and everything set. So we're going to press OK. The board's now going to scan. It's first looking at the blue bus input over here to see if there's a device connected there. If it doesn't find that, it's going to say, okay, is there one of the 2 auxiliary inputs set for pulse open or pulse close, and is there a 300 Hertz pulse device there? And if so, which there is, it's going to go ahead and begin the learning process. Now, had we not connected to this device, it would have given us a blue bus error and told us that at least one monitored safety device is required. In this case, it's going ahead and proceeding with the learning process. It opened just a short bit. Now it's closing all the way to the limit. Just found the close limit. Now it's reopening. It's looking for the open limit. Again, during the learning process, the board is looking for how many motors are connected, what kind of motors, how much amperage the motors are drawing, where the limit switches are set, and it's also looking for the monitor entrapment device, or devices, depending on the situation. So we're almost to the open limit. It reads that limit. Now it's going to close the last time at full speed. And right there's our open limit. And now it's going to close full speed, and you'll see that it's counting down, closing. And we're going to let go all the way to the closed position. And you still see we have a 300 Hertz pulse input right there, indicated by that dimly lit red light. And now we're gate closed. So now if we open the gate, as we're opening, if we break the beam, you'll see that that 300 Hertz pulse input goes out. But nothing happens because we have this photo eye set to protect on the closing cycle, not the opening. So once the gate gets open, I have it set for a very short timer to close, 5 seconds. It's counting down. But if I put my hand in front of the photo eye, you'll see it brings that close timer back to 5 seconds each time. Now I'm going to let it go ahead and close automatically. 3, 2, 1. Here we go. It's closing. Now if I break the beam, it's going to reopen the gate. So that's how easy it is to set up an EMX IRB-RET in a 300 Hertz pulse output mode to a 1050 board to satisfy the UL monitored requirement.